In this video, I'll show an example of how an activity data class area estimate, such as area of forest changing to non-forest, can be combined with an emission factor, such as carbon density of forest, to create an estimate of the total carbon change using the activity data times emission factor formula. In this simple example, I have a population represented by this rectangle. In it, forest has changed to non-forest over a certain time period. So brown is non-forest currently, and the green is currently forest. I have two types of plots. I have plots for estimating the activity data. In this example, it's a 4-subplot cluster design. I have 3 of these. And I have a second type of plot, which is the National Forest Inventory plot, which in this example are only located in forest portions of the population. So here are the 2 summary data tables, which we'll see in a moment. There is 1 row for each subplot. On each subplot, the label assigned is a 1 if the point belongs to a patch of land that went from forest to non-forest. Otherwise, it gets assigned a 0. So we have, in this example, all 4 subplots for plot 1 were converted from forest to non-forest. However, for plot 2, only 2 of the subplots went from forest to non-forest. And for plot 3, all 4 subplots are remaining forest. With respect to the National Forest Inventory plot, I have simply, in this summary table, created the estimate of carbon per hectare at the plot level, at the cluster level. So it's a value per cluster, per hectare. So the calculations that I've done here, using those same data tables for the activity data, I've aggregated that information such that I've calculated for each plot, each of the 3 activity data plots, which just to refresh your memory are these, the proportion of forest that went to non-forest, and then I've calculated the mean, the total, and the total assuming we have 100 hectares in our population, the variance of the sample, the variance of the mean, the variance of the total, the standard error of the mean. Here are t-values, and here are confidence intervals or sampling errors at the specified confidence level. For the NFI data, I've done the same thing. Here's that raw data table, and again, to refresh your memory, it's these 3 plots, these 3 plot level summaries that are used. I've calculated the same summary statistics here. In this portion of the spreadsheet, at the bottom, I've calculated the product estimator using these 2 sets of summaries from the activity data and from the emission factor. One of the goals of this section of the spreadsheet is to show that the estimates of uncertainty calculated using the IPCC guidelines that contain U in them. And if you recall from equation 3.1 from the uncertainty chapter, this is what it looks like, which to me was not very intuitive. I didn't quite understand where they were coming up with this. I convinced myself by calculating it as they describe in IPCC, and then calculating it as is shown through the combination of the variance of the product of random variables, that the numbers are equivalent. Thus, what I think I've shown is how to correctly calculate the product estimator in the context of the activity data times emission factor method of estimating carbon change using the IPCC methods and the textbook combination of the variances, or the product, the variance of the product of two random variables.